Alright, so now continuing with number 5, formula number 5. Okay, so I was doing this with my previous group, but then time was up. Okay, so this one is a bit of a long one, and there will be a part of it which we haven't done yet. It's called integration by parts, but you're going to see now what I'm talking about. It will be the next topic. Right, the ending part I'm talking about, the integration. Right, so here, when you see x squared minus b squared, if you got an x first and you got a minus sign, it's best to use a sec substitution. Okay, so what's going to happen here is I'm going to let x equal to b times sec of theta. Alright, so you're going to see why we do that. So if I go dx d theta, the derivative of sec is going to be sec theta times tan theta. Alright. So now if I make dx the subject of the formula, it's going to be b times sec theta tan theta. Alright. Times d theta. Right, so dx over d theta. Right, remember we're making dx the subject of the formula. Now, if I do the substitution, if I go the integral of x squared, so that's going to be b times sec theta squared minus b squared. Alright, now my dx is equal to b times sec theta tan theta d theta. Right, so nothing complicated. I just use a substitution, put it under the square root there. So now I can square this. This will be b squared sec squared theta minus b squared times your b sec theta tan theta d theta. So now, similar to the other example where I took out a squared, well, there's no a here according to this formula. So I'm taking out b squared as a common factor. Can you all see that? So I'm going to take out b squared as a common factor. So once I take out b squared, I'm left with sec squared theta minus 1. And that's what I want, the square identity. And then I have b sec theta tan theta d theta. So now, here I have the integral of b squared, and we know sec squared minus 1 is equal to tan squared theta times my b sec theta tan theta d theta. Alright, so I use my square identity, sec squared minus 1. Remember, the square identity I'm talking about is 1 plus tan squared bx is equal to sec squared bx. So what happened there is you ended up with just sec squared minus 1, which can be replaced with tan squared. And now, what the whole idea here was, we had two terms. We could not find the square root here and the square root there because of the minus sign separating the terms. If there's a minus or a plus, you cannot go and apply exponent laws. It only works for multiplication and division. Alright, so now it's just one term, I can find the square root. So this is equal to the integral of the square root of b squared, which is b, the square root of tan squared. There's two possibilities, because when you square a negative and you square a positive, you get a positive, but we're only taking the positive here for deriving the formula. Alright, so now the square root of tan squared will be tan there times b sec theta tan theta d theta. Alright, so now comes the integration part. So here we got b times b, which is going to be b squared, and then we got tan times tan, which is going to be tan squared theta times sec theta d theta. Now, we got a problem now, because this is not an exact derivative, okay, which I was trying out with my other group too. I tried to let u equal to sec, which you can try out very fast, and I already know it doesn't work. If you let u equal to sec, you get sec times tan, then sec cancels, and you get tan, but there's tan still remains there. Okay, you can try that out. You can try and change tan squared to sine squared over cos squared, sec 1 over cos. You're going to have powers of sine and cos, but you're going to end up with sine squared cos to the power minus 3 there. We got a problem there also. Okay, so I realized that this is integration by parts. Okay, so you are going to be lost when I'm doing this here now, but it is the next topic after this here. It's called integration by parts. Alright, so you can just watch and listen here what's happening. Right, with integration by parts now, the formula for integration by parts is, let me write it down, which you are going to be doing next. So we're going to go f times g, f of theta, g of theta minus the integral of g of theta times f prime theta d theta. Okay, so there is a priority list for choosing here. I'm not going to get into all that now because I'm still going to explain that to you. But you watch how complicated this gets. Alright, so my f of theta I'm going to choose as, I need to write this one down. So when you do integration by parts, then you need to identify your f. So I'm choosing my f of theta as sec theta. So f prime theta, the derivative of sec will be sec times tan. Then I'm going to go g prime theta, and my g prime I'm taking, there's two factors there. I'm taking one as sec, the other one is tan squared. So my g prime is tan squared. I need to integrate tan squared. So in order to integrate tan squared, I need to change it to sec squared minus 1. This is powers of this, you understand. This is powers of certain parts you will understand. Okay, but you won't understand why I'm going, which is f, which is g prime. But this is the part tan squared. I can change into sec squared minus 1. This is powers of tan. So when I integrate sec squared, I get tan theta. When I integrate 1, theta. Right, so I'm going to substitute into this formula now. So I'm going to substitute f of theta, that is sec theta times g, which I just found now. You'll always be doing this for integration by parts. Write this down, write down the formula, substitute. So that's f times g minus the integral. You see this formula also has the integration sign in it. G, which is tan theta minus theta, times f prime, which is sec theta tan theta d theta. Alright, now, well, this is a good example for the N6 students too, but also for N5. Integration by parts is both N5 and N6. Alright, so now what am I going to do? I'm going to try and simplify this here. So what do I have? Sec times tan, that will be sec theta tan theta, and then sec times minus theta will be minus theta times sec theta. Alright, I think I should multiply the b squared into, but I'll do that just now. Alright, let me just deal with this part here. So what is going to be happening here now? So what I'm going to do now is I'm going to remove these brackets. Minus tan, well, I'm going to go minus sec tan times tan, and then minus sec tan times theta. I'm removing the brackets completely here. So this is going to be minus the integral of, so sec tan times tan will be tan squared theta times sec theta d theta. And then sec tan, well, minus sec tan times minus here will be a plus theta times sec theta tan theta. Okay. Yeah, plus the integral there d theta. Okay, so we got that part. Now, let me just remove this b squared here. So what do I have? I have the b squared, which is in front. I'm just going to multiply it inside there. Or, before I do that, I notice there's a term here, theta times sec theta tan theta. Now, this is integration by parts, again, for the second time. When you do integration by parts, certain examples require you to apply the formula 3 times, 4 times. Here, I'm applying it for the second time. Alright, so here, I got theta, sec theta, tan theta. This is integration by parts. I'm going to write down the formula. So I got my b squared there. I'm going to remove the brackets just now. Right, so theta times sec theta tan theta. I'm going to apply the formula for the second time, which is f of theta g of theta minus the integral of g of theta times f prime theta d theta. Okay, so what's going to happen here now is I got my sec theta tan theta minus theta sec theta, and then you can see this takes long to write down. Right, so now my f of theta here, which you will learn when we're doing this section, is going to be theta. Let me just write it down one more time, because you are going to be re-watching this here, then you'll understand. So my f of theta here is going to be theta. How do I know that? From a priority list, which I'm still going to explain to you. Right, you get a priority list for choosing f of theta. So f prime theta is equal to 1. Then I got my other factor here. I'm talking about this one here. Here's it here, which is sec theta tan theta. So g prime theta is equal to sec theta tan theta. So I want to get g. So I'm doing the reverse process here. If this is g prime, g means integrate sec theta tan theta. And what if this you will understand? If I integrate sec theta tan theta, I get sec. Alright, so now I'm going back to this formula. So what do I have here now? I have f of theta, which is theta. G is sec theta minus the integral of g, which is sec theta, and then f prime theta, which I have there, is 1. Okay, now let's see what happens. Okay, let me write this on the top here now. So what did I have originally here? This is it. So I got b squared times the integral of tan squared theta sec theta d theta is equal to, where am I copying from this side? I'm going to remove these brackets here. So I got b squared times sec squared tan, which is equal to b squared sec tan. Okay. Before I continue here, what do you notice about these two terms here? I got minus theta sec theta plus theta sec theta there. Right. It will give you 0. Right, so now the only part I need to do is this part here. But what do you notice now? I use the formula. I use the formula twice. This is the integration by parts formula first time. This is the second time. And when I used it the second time, well, let me just see here. We get back to the question now. Look at this. Tan squared times sec. And what was the question? Tan squared times sec. Okay, so watch what's going to happen now. Right, so I'm removing the brackets here. B squared times that. And then I got b squared times minus tan squared sec, which is minus b squared tan squared times sec theta d theta. Alright, so where am I now? I know that that and that cancelled. Well, it was 0. Okay, so I got minus b squared, and here now I'm multiplying b squared times minus 1, which is minus b squared times, and then I need to integrate sec. Right, so when I integrate sec, you can go to your formula sheet there. It will be ln of sec theta plus tan theta. Alright, now you're almost done over here. So what do we notice? We used the formula twice, and then we ended up back here. So what I can do now is I can take this to the other side. What will happen if I take it to the other side? I'm going to have b squared plus b squared of the same thing. Alright, so if this was k, let's just say this was k. So I've got minus b squared k plus b squared k. So if I take it to the left, it's going to be b squared k plus b squared k, which is 2b squared k. So basically I'm going to have 2b squared times the integral of tan squared theta times sec theta d theta is equal to what we have here, which is b squared sec theta tan theta minus b squared ln sec theta plus tan theta. And now I can divide here. So that's going to be, let's see, the integral of tan squared sec theta d theta is equal to, let me just see here. Right, the integral of tan squared sec squared theta is equal to b squared sec theta tan theta. What was the original question there? Sorry, I had my b squared here. Okay, so it's going to be b squared tan sec theta tan theta minus b squared ln sec plus tan. So that's sec theta plus tan theta. And now notice there's no integration here. Okay, sorry. Yeah, let me just go back here. So this was 2b squared. So what I'm going to do is I'm dividing everything by 2. So I'm dividing by 2 there, dividing by 2. I'm leaving the b squared on the left hand side because the original question had b squared there. Can you see that? Alright, now we've integrated everything here because there's no more integration left now. Can you see that? So we put down plus c. Alright, so now let's start substituting. We're almost done now. Alright, so we got b squared over 2. Now I need to substitute back now. The integration part is done. Alright, so I got my b squared over 2 sec theta. Let's go for sec theta now. So now let's go back. What is sec theta? If I make sec theta the subject of the formula. Okay, let's write it down there. We know that sec theta is going to equal to x over b. Alright, so I know that sec theta is going to equal to x over b. What about tan theta? Do we have a substitution for tan theta? We got a problem now. We need a substitution for tan theta also. So, all you do is you use SOHCAHTOA. This is trigonometric substitution. Okay, so what do we know about sec? Right, so you know that cos is adjacent over hypotenuse. So that means sec is going to be hypotenuse over adjacent. So that means sec theta is, that means the hypotenuse is x, so there's my x here. And the adjacent side is b, which is next to. So now I can use the theorem of Pythagoras and work out this side here. Let's call this P, Q, R. Alright. So if I use the theorem of Pythagoras there, let me just do this here. The square of the hypotenuse is equal to the sum of the square of the other two sides. So it's going to be x squared, which is the hypotenuse, opposite 90 degrees, you can see that, is equal to the sum of the squares of the other two sides. So one side I already know, which is b. This side is the side that I'm looking for. I just called it PR squared. So now I need to make PR the subject of the formula. So it's going to be x squared minus b squared is equal to PR squared. So what is PR? So PR will be the square root of x squared minus b squared. Alright, so I got that sorted out. What do I want? I want tan. So I know that tan is opposite over adjacent. So opposite theta is the square root of x squared minus b squared, and adjacent is b. Adjacent is b. Okay. Now, so I got my tan theta there, which is, there's a here, the square root of x squared minus b squared all over b. Okay. Now, so I got sec theta, I got tan theta minus b squared over 2 ln. So what is sec theta? X over b. Where is it? Sec theta is here. X over b plus, what is tan theta? The square root of, where is it? My tan theta is here. Okay. That's the square root of x squared minus b squared all over b. Right, now let's see. How are we comparing it here? It's almost, it just needs a more simplification now. Can you see? Watch how it's going to be simplified now. Alright, so here. So b times b is b squared. So b squared in the bottom, b squared in the top. Cancel this out. So I got my x over 2 times the square root of x squared minus b squared. Okay, that formula, I hope you understand that it deals, there's two formulas here. I just chose to show you the one with the negative. Okay. So I got the first part. There's a here, x over 2. If we are using the minus, then it's x squared minus b squared. Minus now. Okay, now notice the formula. Okay, you can't really see it at the moment. But this is minus b squared over 2. And this is going to be ln x plus the square root of x squared minus b squared, all divided by what? Divided by b, because I have an LCD there. Now, here's my x over 2. Watch what I'm going to do now. Alright. Notice the formula doesn't have any b there. Can you see that? So, here, okay, what I can do here is, I can write it as, let me just see here. Yeah. that's b squared over 2 there. So I can write this as ln of the numerator minus ln of the denominator there. So I can go, okay, that's ln of x plus the square root of x squared minus b squared. Okay, let's do that. Minus ln of b. Let me just see if that will work. Alright, so if I have to remove the brackets now, let's see what will happen here. So I got my x plus the square root of x squared minus b squared all divided by b there. My set was x over b. Tan was the square root of x squared minus b squared all over b there. So let me just see. Is there anything that I'm missing for it to cancel there? I don't think so. Okay. If I remove the brackets here, so that becomes minus b squared over 2 ln of x plus the square root of x squared. There's another class coming in here. B squared, and then a minus and the minus will give me a plus b squared over 2 ln b, which is basically, there's no x here. Can you see that? So remember, I didn't put down. There's my plus c. This can be added all to the constant there. So this is negligible. When you are working out area, okay, or volume, which is coming up in the next chapter, you don't have to worry about the last part. So this is a complicated one. Okay, but I said let me just do it to show you the integration by parts.
So how much would a question have been?
100 marks. I'm joking.